Have you ever wondered how a nuclear power plant functions? How does something so small as an atom generate such massive amounts of energy? Today, we delve into the world of nuclear power, where we'll unravel the mystery behind this powerful and intriguing technology. Did you know that nature beat us to the punch when it comes to nuclear reactors? Yes, you heard that right. The Earth had its own nuclear reactor long before we humans figured it out. A prime example is the Oklo Natural Nuclear Reactor in Gabon, Africa. This natural phenomenon operated nearly 2 billion years ago, showcasing the immense power of nuclear energy, even in nature. So, before we delve into man-made nuclear reactors, let's appreciate the power that nature harnessed billions of years ago. Nuclear energy stems from the nucleus of an atom. Atoms, the tiny particles that make up every object in the universe, hold an immense amount of energy in their nucleus, or core. The process of releasing this energy is what we call nuclear reactions. There are two types of nuclear reactions: fusion and fission. Fusion occurs when two atoms join together to form a larger atom, while fission is the splitting of a large atom into two or more smaller ones. Nuclear power plants use the latter, nuclear fission, to generate electricity. Imagine a game of pool. The cue ball represents a neutron, a particle found in the nucleus of an atom. When this neutron strikes the nucleus of a uranium atom, the nucleus splits, releasing a great deal of energy. This is nuclear fission. But it doesn't stop there. The splitting of the uranium atom also releases more neutrons, which then collide with other uranium atoms, causing them to split and release even more energy. This chain reaction is the heart of a nuclear power plant. But how is energy won from that? Let's delve a bit deeper. After nuclear fission takes place, a huge amount of heat is generated. This heat is what we need to capture and convert into usable energy. This is done through a complex heat exchange process. The heat from the nuclear reaction is used to heat up water, turning it into steam. This steam is then directed at high pressure towards turbine blades, causing them to spin. This spinning motion is then converted into electrical energy through a generator. So, in essence, the energy from the nuclear fission is transferred into mechanical energy and then into electrical energy, powering our homes, businesses, and cities. In conclusion, nuclear power plants harness the energy stored in the nucleus of an atom through a process called nuclear fission. The heat generated from this process is used to create steam, which drives a turbine to generate electricity. The waste produced by these reactions is carefully managed due to its high radioactivity. Nuclear power is a complex yet fascinating technology. It holds the potential to generate vast amounts of electricity, but also poses significant challenges, particularly in the management of radioactive waste. As we continue to seek out sustainable and reliable sources of energy, understanding the workings of nuclear power plants becomes ever more important. Remember, every atom holds a universe of energy. It's up to us to harness it responsibly and safely. Let's take a moment to discuss the role of nuclear energy in our transition to cleaner energy sources. As we strive to reduce our reliance on fossil fuels, nuclear energy emerges as a viable option. It is carbon neutral, making it an eco-friendly choice when compared to traditional power sources like coal or gas. Nuclear energy is often seen as a transition energy, a bridge that can help us move from our current state of energy production to a more sustainable future. It provides a reliable and efficient source of power that can support us while we develop and implement renewable energy sources like wind, solar, and even fusion energy. Of course, like any technology, nuclear energy is not without its risks. The Chernobyl disaster serves as a stark reminder of what can go wrong. However, when compared to the continuous and widespread damage caused by coal power plants, which contribute to air pollution and health issues, nuclear energy seems like a safer bet for our transitional phase. So, while nuclear energy has its challenges and risks, it's an important stepping stone in our journey towards a cleaner, greener future. As we continue to innovate and advance in the field of energy production, it's crucial to keep an open mind and consider all options.